Welcome to the first video lesson dealing with fluids. And here we will be looking at the key properties of fluids. So now fluid simply means a substance which can flow. Let's take a simple example to go into the further details. Suppose this is, of course, it's a straight line. Suppose this is a container and which has a carrying capacity of around 9 liters, and you have water which is filling it up to a level of 6 liters. Now this points to a very important property of fluids, that is it conforms to the shape of the container. This simply means that it doesn't have a particular shape. Now, if you tilt this container something like this, it simply means that the fluid will actually take a shape like this. And of course, if you further tilt it, it is going to flow out. Now, what does it mean? To further understand the properties, we have to look at what is happening at the molecular level. Now, it simply means that if you are taking a cross section, it simply means the molecules. That is the intermolecular force. I am taking this particular section out. This is the water, and you can see that the intermolecular force of attraction is in such a manner that it's between that of solids and gases, which simply means you may say that it's something like an average to a certain extent. An average between the intermolecular force of attraction is an average of that kind of force between solids and gases. So what does it mean? It simply means that to a certain extent the whole substance can change its shape, or can actually slide over. It simply means that if you have two molecules like this, there's a molecular force of attraction. Because of the fact that it isn't strong, it's strong enough to maintain that force of attraction, and it isn't weak enough to break that force. It simply means that one molecule may be a molecule may slide over the other molecule to a certain extent. So this property of sliding it is one of the key properties of fluids, and it gives rise to important features of fluids, like viscosity. Now, when we say that fluids refers to a substance which can flow, it simply means that we are not only looking at liquids, we also had to include gases, because gas is a substance which can flow. So what's the key difference? The key difference is that whereas liquid, as I already stated at the beginning, conforms to the shape of the containing vessel, the gases doesn't conform. Isn't restrained to the shape of the vessel. Another point is that as far as liquids are concerned, liquids can be compressed, but only to a certain extent. So after a particular extent, after uh, uh, if you exert a pressure, or if you try to decrease the volume of the liquid, or after a particular stage, it is in incompressible. Now, as far as gas are concerned, to a huge extent, again, on can say we can say that it can be compressed to infinity or something like that, but to a considerable extent, gas are compressible. And the reason is that, of course, as the intermolecular force of attraction is very weak, they can move freely, which simply means that you have a very good chance at compressing it. Now, another key point about liquids is that I mean, because of the fact that they take the shape of a container, it means that liquids will have a free surface, which simply means that, as I have already shown at the beginning of this particular lesson, there will be free space in a container. I mean, if you are pouring 6 liter of water into 9 liter, naturally 3 liter of space would be weakened. But such a thing is not possible in gas, because as gas spreads out, and so it spills the entire possible volume. So it simply means that you will not be having any free spaces. Now, fluids, now coming into the theoretical aspects. Fluids actually, we study fluids under two headings. As first is what is called fluid statics, and the second division is of course it's what is called fluid mechanics. Now many students have feeling that both are same, but there's a key difference. Now, fluid statics means that we are dealing with the property of the fluid when it is when the fluid is at rest. And in fluid mechanics, naturally it means that the fluid or the either the fluid is moving, or the container having the fluid is so the fluid is in motion. Now, in rust, actually, it's not I mean, the calculations, the aspects are not very tough. It's quite simple. In the case that the usual, I mean, laws of motion can be applied here. So usual laws can be applied here. But in the case of fluids which are in motion, things become quite difficult. Now, we can look at a simple case to understand why it's so. Suppose you have a okay, I'm going into the previous example for its simplicity. You have a vessel containing the fluid, and it's on a kind of platform which can be moved. Now at rest, of course, the key properties are stable, and when if you allow the platform to accelerate, what happens to the fluid in the container? Naturally, if the direction of acceleration is in the direction pointed by the arrow, what happens is that the fluid will take a shape like this. Yeah, it's so you have a angle which is formed at this particular position. It simply means that, I mean, if you take two portions, I mean, if you divide the whole thing into two sections, something like this. So the amount of weight which is acting downwards in this particular portion is different from the other portion because the volume of liquid which is filling the container is different in this two portions, which simply means that the factor, I mean the acceleration which is acting on the liquid is also different across this particular gradient.